Hey guys, Mr. Bowman here. In this video, we are focusing on 1.2 Algebra. That's the MCAT. And in this video, we're focusing on all the excellence questions from the 2015 exam. So question number 1 is where we're going to start off with. So I'm just going to jot down question number 1. And we've got two people, Sam and Jake. They live 8 kilometers apart. Sam skateboards 10 kilometers at the same time that Jake rides his bike 15 kilometers. If both of them leave at the same times and travel towards each other, how far from Jake's house will they meet? So just representing this as a picture, sometimes I struggle. So I'm going to have Jake over here and I'm going to have Sam over here. That's their house. Jake is going to travel in this direction on his skateboard. Sam is going to travel in this direction on his bike. And we're trying to find out, when do they actually meet? And specifically, we're interested in the distance from Jake's house to that meeting point. So I'm going to start this video or this question by just defining what we're going to do. So we're going to go let J equal distance from Jake's house. And I'm going to do the same for S. Let's let S equal the distance from Sam's house. Okay, I don't think this is required, but it just gets me thinking about the variables in a bit more detail. The first bit of information I can see that 8 up there. And when we're doing this here, we know that the distance from Jake and the distance from Sam, because they comprise of the total distance from Jake to Sam's house, they must be equal to 8. So the distance Jake travels plus the distance Sam travels must be equal to 8. The next one's a bit trickier. That's that kind of middle-y sentence there. Sam travels 10 kilometers on a skateboard at the same time Jake travels 15 kilometers. And this one's a bit tricky, but I need to think, when does Jake equal to Sam or vice versa? And I'm thinking 15 and 10. I'm thinking of the lowest common multiple. The lowest common multiple. And in this case, that's going to be equal to 30. So to get Sam to 30, I need to multiply his distance by 3. So I'm going to go 3 times Sam. And you can see I've changed that down below. And because Jake was on 15, I need to multiply by him by 2. So what that eventually gets us, it says 30 equals 30. So that equation is balanced, and we can go ahead and use it for the rest of our working. At this step here, just need to think, we're trying to find out Jake's distance. So I need S by itself. That way I can put S in over here, and that will leave the J's only. So from this equation over here, we're going to go minus J, which leaves S equal 8 minus J. I can now substitute this S in over here. So I'm going to do my working over here. I know it's getting a bit messy, but we've got 3, and then we've got bracket 8 minus J. That's where the S was, and now it's gone. And that should be equal to 2J. Now here, it's actually quite a simple linear equation. I'm going to go ahead and expand my brackets. 8 times 3 is 24. Then we've got negative 3J. That is equal to 2J. I'm going to go plus 3J to get all the variables on one side. So 24 is equal to 5J. Forgive me that my J's look a little bit like 5s, but they are J's. And at this stage here, I'm going to go divide by 5. So I know 4.8 is equal to J. So that means these two, Sam and Jake, they will meet 4.8 kilometers away from Jake's house. So let's put that in a sentence because it is an excellence questions. Sam and Jake will meet 4.8 kilometers from Jake's house. And that wraps up that question. We are now moving on to question number 2. Quite a short question. Let's run through it. Danny is trying to find a value for C so that x squared plus 6x plus C only has one solution. We've been asked to find the value for C and to solve the equation. For me, the initial step I'm liking is I'm seeing one solution. And one solution, when you think of quadratics, normally relates to a certain type of quadratics, and that's a perfect square. And if you can't remember what that is, just a reminder, that is something like x plus 3, x plus 3. So we've got the same bracket twice. So we end up doing x plus 3 squared. So I've just made up these numbers here just to show you what a perfect square is. We're then going to get into the question. So we've got 0 is equal to x squared plus 6x plus c. And just to the right of my page, I'm just going to mess around with some math. So let's say we had x plus a squared. If we expanded that, that would have been x squared plus 2ax plus a squared. So the number at the end would have been half of the value out the front. And if we link to that, so 1/2 of this number here is equal to 3. And we're going to square it to find c. So 3 squared is equal to 9. So we know our factorized quadratic is going to be x squared plus 6x plus 9. And I think this is funny because I actually think the example I gave you, ironically before, actually might be the answer by the looks of it. We factorize that because we have been asked to solve it now. That's x plus 3, x plus 3, because 3 plus 3 is the 6. 3 times 3 is that 9, which means 0 will be equal to x plus 3 squared. If I square root 0, that's going to become 0, so we're going to get rid of the square. So 0 equals x plus 3. And to finish off my answer, I'm going to go minus 3, minus 3. So x is equal to minus 3. So fairly straightforward question if you got this one solution perfect square trick. And I did think it was quite funny that by chance the example I gave you ended up being most of the working. On to question number 3. This one looks a bit messier all the way down the bottom there. So Tane's asked to solve this equation. He's got the following working here. We'll have a look at it later. And he's got 2 answers. Tane's teacher tells him that he's wrong and that there's only one solution. Explain Tane's mistake. So normally what happens is when there's one solution, that normally means it's a linear equation or it's a perfect square. We dealt with perfect squares in question 2, so probably a linear equation. And looking at his working, you can see the denominator here. He's moved it to the other side over there. And what happens when he's done that is you can see we've got x squareds everywhere. And those x squareds make it a quadratic, which probably means there's going to be 2 answers. And it looks like that's what he's done wrong. So what I'm thinking he needed to do is that quadratic fraction that I'm circling excessively on the left, that quadratic fraction probably needed to simplify that. And hopefully we can get rid of some of the x's, which would leave an x as opposed to an x squared. So let's jot it down. So we've got x squared minus 1. And straight away I know that's a perfect, or difference between squares. That's going to be a double bracket. And down the bottom we've got x squared plus 2x plus 1. And that there is equal to 3 quarters. So let's factorize the top there. We've got x minus 1, x plus 1. Down the bottom, what adds to 2 multiplies to 1? That's going to be 1 times 1, 1 plus 1. So that means down the bottom, it's going to be x plus 1, x plus 1. And I'm liking what I'm seeing here, equals 3 over 4, because I can cancel out some brackets here. 1 from the top, 1 from the bottom. So we've got x minus 1 over x plus 3, or x plus 1 equals 3 over 4. And this is really good. That quadratic part of the question's now gone, which makes me think I'm going to get one answer. And that's consistent with what the teacher said. So let's do a bit of a cross-multiplying method. So we've got 4x minus 1 is equal to 3x plus 1. Expanding everything, 4x minus 4 equals 3x plus 3. So we're going to go minus 3x, and we're going to go plus 4 at the same time. These cancel, means x is equal to 7. So we got one answer. So I'm liking what I've seen. The part of the question, it did say explain Tane's mistake. So just in words, we need to explain that Tane did not simplify the quadratic fraction on the left-hand side, and he should have done that. So Tane did not simplify the quadratic fraction. quadratic fraction on the left-hand side. And I'm going to go LSH, which is a shorthand for left-hand side, which he should have. Right, should have. There we go. So that's question 3. Bit of a tricky one, but we got there in the end. Now on to question number 4. Reading through the question, we've got a group of people who've gone to the fun park. There's 38 people in the group. Students cost $10 each. Adults cost $20 each. The total group for the cost is $420. We've specifically been asked about the number of students in that group. So because it's a wordy question, the first thing I want to do is I want to go ahead and start defining my variables. So I'm going to let A equal the number of adults in the group. And S will be students. So the number of students in that group. Once we've defined these two variables, which I'm finishing up now, we need to think of some equations, some relationships between the numbers that we were given. The nice one relates to that 38, and that's because I know the number of adults plus the number of students, that has to come to the total, which is 38. So the A plus the S has to equal to 38. So that's the first nice, easy relationship. The next one is going to have to do all those cost information that I've been given. So the total cost of the students will be 10 times S, because each student will cost $10, and then adults will be 12 times A, and they combined have to get to that $420. So what I'm going to do, just in alphabetical order, I'm going to write 12A plus 10S has to equal to $420. Remembering we've been asked specifically about the students, that means we need to get A as the subject of the equation, and this one on the left looks a bit easier, so I'm going to use that to deal with it. So getting A by itself means I need to go minus S, so that means A will be equal to 38 minus S. Now this means I can take away the A and substitute in 38 minus S, and I'm left with S's only on that second equation. So let's do that here. So the A over here is going to go away, so we've got 12 bracket 38 minus S, and that is from over here, which is what A is equal to. We're going to add 10S, and we're going to equal to 420. We're now going to expand the brackets. 12 times 38, 456. So that was that timesing. We're now going to do that minus 12S plus 10S is equal to 420. Bit of simplifying here. Let's group these S's together. We've got 456 minus 2S, that's equal to 420. I'm now going to take away that 456 on both sides, get the letters by themselves. We've got minus 2S is equal to negative 36. We've got a negative sign on both sides, so I'm just going to get rid of that. And then final step, divide by 2, so S is equal to 18. That means there were 18 students in the group. We don't really need to do any wordy explanations here because we've defined S and we've calculated S down the bottom there. On to question number 5, and we've got Sarah and Marie, forgive me if I'm saying that wrong, are studying for the NCAA exams. Sarah claims, so that word claim is always a good word to keep an eye out for, normally an excellence question, but Sarah claims she studies for more than Marie. So interesting claim. Marie says she studies 3 hours on each day, 4 days a week. Sarah says she studies for 2/3 of that time during the week, but she does a little bit of extra study on the weekend. We've been asked to assess if Sarah's claim is a correct one. So my starting point for this, well, let's think about Marie, because Marie's the one we're kind of benchmarking or comparing it against. So Marie, she worked or studied for 3 hours on 4 days, which means she studied 12 hours per week. So that's an easy one to calculate. Sarah's one's a bit messier. And that's because it said at least 2 a week. So that means there's a bit of an inequality or conditional element to it. But let's say she works on the minimum. So 2/3. So 2/3 times Marie's 12 plus 2. But just a reminder, that plus 2 at the end, that may actually go up. So 2/3 of 12 is 8, plus the 2 is 10. So we've got 10 hours for Sarah. So already we know that the claim is absolutely rubbish because Sarah is studying for 2 hours less than Marie at this instance here. But there's a bit of a conditional element because she could study a bit more than 2 hours if she wanted to. So what I'm going to do is I'm going to say, let S equal the number of hours studied by Sarah. And we'll write in a week. Oh, that's messy handwriting. Okay, there we go, in a week. So I suppose we're just going to think of inequalities. If she studies for 2 hours or up to 4 hours, but not quite 4 hours, so it's not equal to 4 hours, when in that range, so 2 or more, all the way up to 4, Sarah definitely does study less than Marie. So Sarah studies less. If she studies 4 hours exactly, so if S was equal to 4, Sarah studies the same. And then the final one, if she goes beyond that 4 hours, so if S is greater than 4, this is when Sarah's claim is actually correct. That's when 4 or more, so that's Sarah studies more. So thinking about Sarah's claim, is she always correct? No, she is not correct. So just down the bottom here, Sarah's claim is incorrect because, and we'll justify a reason, because she studies less when, and then that first criteria, when she studies between 2 and 4 hours. So a bit of a weirder question, not actually much algebra there, but a good application of inequalities and understanding that there. On to question number 6. And we've got Sammy, and I think Marius is how I say that. Marius earns $14 an hour. Sammy earns $4 an hour, so that makes Sammy $18 per hour. Marius works twice as long as Sammy. They earn a total of $138. How much does Sammy earn? So this one's going to be a bit messy. So I guess the first thing we can do is we can form a relationship with the total. So we know, we're going to define, let's say M is equal to the number of hours worked by Marius. And then we're going to say S is the number of hours worked by Sammy. So I just did those little comma marks just because I'm being a bit lazy there. So let's get into the maths of it. We know that 14 times the number of hours that Marius worked plus 18 S, which is the number of hours Sammy worked, that should combine to get 138. So that's the easier one. This messy one here is where the second part of it comes. So we know that Marius works for twice as long as Sammy. So when this happens, I just make up some numbers. So let's say he earns 10, twice as long as Sammy, which means Sammy had to earn 5 or work for 5 hours. But the only issue is these numbers aren't the same. So to make them the same, I'm going to go times 2, which would get to 10. So that means it's 2 times S is equal to M. So M is equal to 2 times S. So in our case, that would have been 10 equals 10. They're balanced. Not a lot of rearranging. This is actually quite a nice question. So M, this 2S, we're going to put it over here where that M is, and we're going to have an equation just for M. So we've got 14 times 2S plus 18S is equal to 138. And I like this because S is the only letter left, and we are trying to figure out how much Sammy earns. So it means we're in a good spot. So that means expanding this bracket, that's 28S. So 28S plus 18s is equal to 138. That means 46s is equal to 138. S is equal to 138 divided by 46. I wouldn't do this math in your head. I'll definitely get a calculator to double check, but that does get us to 3. So S is 3. S is how much our Sammy worked. So we're going to write Sammy worked for 3 hours. The only thing is, we were actually asked how much does Sammy earn, so we need to multiply that. So 3s will be equal to 3 times 18, which is equal to 54. So that tells us she earned $54, which is $54 in earnings. 7, the final question of the 2015 excellence stuff. And breaking into it, so we got the volume of a cylinder and the volume of a cone, and we've been told that they both have the same radius. If the cylinder has a volume twice of the cone, give the ratio of the cylinder heights, basically. So what I'm thinking here is, if we multiply the cone's height by 2, that should be equal to the cylinder's height. And that's because, as we've seen here, the cylinder's volume is twice that of the cone, which means 2 cones should be the same as that cylinder. So we can form a bit of a ratio from this here. So we know that 2 times the volume of a cone, which is given to us over here. So it's going to be pi over 3 r squared times height, and I'm going to do the ratio dots instead of an equal sign. The equivalent would have been the volume of the cylinder, which is pi r squared h. Thinking this as a bit of an equation, we know that the radius is the same, so the radiuses are actually going to cancel each other out. So 2, and I'll simplify this, pi over 3 height should be equal to pi of the height. The pi's will also cancel each other out. So 2 over 3 of the cone's height should be the same as 1 lot of the cylinder's height. We're also going to cancel out the ratios. That means 2 over 3, or that h's, should be equal to 1. We've got a bit of a fraction, so we're just going to simplify it a little bit more. I'm going to times this side by 3, times that side by 3, which means we've got these cancel each other out, leaving 2 to 3. So that means for the height of the cone, for every 2 units, the height of the cylinder should be 3 units. So, bit of a weird question. We've used some equation skills, but certainly in a ratio setting. So that wraps up all of the excellence questions from that 2015 exam. If you're looking for more revision materials, check on YouTube, check the quickmaths.co.nz website. Hopefully you'll be able to find some more.